So I'm going to work on a compiler for a small language I'm calling Fin. It's going to be a general purpose programming language, and it's initially going to be written in Go, though the eventual goal will be to rewrite it in itself to self-host. So the first thing I need to do is start tokenizing some input. So we'll start with the token package, and I basically already know what I want to do to achieve this. So we'll have a token type, and I'm going to represent tokens as a struct that has a kind, a start index, and an end index. So these indices will basically be used to get a substring or a slice of the original source string to get the lexeme that's associated with the token. And they're 32-bit integers because 16-bit would be too small. That would only let us go into 64 kilobytes of original source at a time. 64 bits is too big, and so 32 is the middle ground. These could support up to 4 gigabytes of source at a time if they were uints, but the negative numbers are useful to have as sentinel values sometimes, and 2 gigabytes seems like enough. So kind will also be a 32-bit int because it's going to get padded out in this struct anyway. So we need some token kinds. We'll start with unknown, and this will be used to group any run of characters that we don't know how to classify yet. There's EOF, so the parser knows where to stop. We're going to have function, return, ident, and int. And if we go to the readme, there's a small example of what I want to start by compiling. So this is the function keyword, return keyword, identifiers, and integer literals. And the rest of it is just punctuation. So there's basically, it's C-like, so there's parens and curly braces. There's also some arithmetic operators, and we'll require that statements are terminated by a semicolon. So since the rest is just punctuation, we'll have L paren, R paren, left and right braces, comma, semicolon, then we need plus, minus, asterisk, and slash. So when I print these things out, it'll be useful to see the actual token name instead of just the integer that's been assigned by the enum. So I'll just implement the stringer interface on kind. And since it's an enum, I'm just going to do it as a static table because that can be done using the enum values as the indices, and then they can just map to their names. But I'm going to change the names of the punctuation to the actual punctuation. It would also be useful. Oh, actually, I think when I get to the parser, the way that I'm going to initially check that it's working is by marshalling it as JSON. So if I implement marshal JSON here as well, then I can see the kind name in the JSON that comes out. So we'll just say that this is a byte slice of k.string, and we'll return nil error. And then it would also be useful to have a constructor for the token. So the other type that I want to have in the token package is a file type. So this will just be used as a container to store the original source, the name of the file for things like error messages, and it can be what the scanner will basically populate a slice of tokens in the file. Then that way I can just pass the file to the, for example, the parser or the type checker, instead of having to create a dependency with the scanner everywhere. So package token type file. So this is going to have a file name. We'll have the original source. And then we'll just have a slice of tokens that have been tokenized. So we just need a scanner now. And this will just need to keep track of the file that it's currently working on. So this is going to be token file. We'll keep track of the position that we're looking at within the original source string. And we'll keep track of the next byte that we're looking at so that we can know what to do next. And I'm just going to have a main scan function. So this will just take in a file. It can reset its internal state. So we'll say file is file, s.pos is 0, and then s.next is s.file.tokens, and this will be whatever s.pos is. But this will only work, obviously, if s.pos is within the bounds of the... Oh, sorry, not tokens. This will be source. It will only work if it's within the bounds of source. So we need to check that against the len of s.file.source. If we're out of bounds, then we'll just set it to some sentinel EOF value. And what we should probably also do is set the tokens to nil as well. So scan resets the internal state and it clears out all the tokens that might be in the file for whatever reason. And then what it needs to do is loop around consuming tokens and populating the token slice in the file. So we basically need to say have a for loop here where we'll consume a token. So this will be whatever the next token is. We'll add it to the s.file.tokens slice. And then if that tokens.kind was EOF, we'll break. So we're going to need a consume function. This will basically just look at the next byte and decide what token to create. So we could do, for example, return token.new token.eof, and then we'll pass in the start position and the end position. The auto import thinks that I want go token, so we'll just see if it gets the right thing this time. That's it. And we should probably have some tests. So we'll say scanner tests.go. We'll say test scan or test scanner. So this will be testing.t. And then the way that I want to use this test is to set up a scanner, or we'll set up a file first. So we'll say token new file. This will take some name of the file, so this can be scanner.fin. And then we're going to take in all of our tokens. So we've basically got a function keyword. Maybe I'll put these on different lines, so we different columns and different lines, so that we can test things like line and col numbers as well. So we'll have a function return. Let's see, we want identifiers, which could start with an underscore or a letter, and be followed by letters, underscores, or digits. So we'll do a couple of different identifiers. I think that would do for now. Maybe we'll have one with an underscore on the end. Then we've got integer literals. So 1, 2, 3. Maybe we'll do one of each. Then we've just got punctuation. So we're going to have the parentheses, the braces, the comma, the semicolon, plus, well, maybe we'll put the arithmetic ones on their own line, plus, minus, multiply, divide. And then at the very end will be the EOF. So what we'll do is create a scanner. Maybe for this I'll just say scanner.new and then directly call scan on it, passing in the file. So this scan should populate the tokens in the file. And then our test cases will basically just be the tokens that we expect. So what kind do we expect is what we'll start with. So we'll just say token.kind. And then we'll just loop through all of the tokens. So we'll say token range over file.tokens. If we go higher than the number of test cases we've got in the test table, then we'll just assume that we've got too many tokens. So if I is greater than the length of TT, or maybe this should go before. So if the length of the file tokens is greater than the length of the table, then there's no point, we've got too many tokens. Maybe what we could do is say we want this many tokens, but we got this. So want and got. Equal these lengths, and if want does not equal got, then we do the fatal error. Otherwise, we'll look up the test case. So the test case will be TT sub I. And then if the test case kind does not equal the tokens kind, then we'll generate an error. So we want token kind, this got this, TC kind and token kind. So file needs a tokens. Okay, tokens is just missing the S. And in the test table, I need to actually initialize it. So here we go. Fatal F. Yes, I need to pass in want and got. Okay, so want 0 tokens, got 1. That's because we're returning a hard-coded EOF. So basically, we'll just create a new test case for all of these tokens. So the kind that we expect from each of these is token.function. Token.return, token.ident, that's going to be for each of these. All of these ones are just going to be token.int. Then we've got token.lparen and a copy of that for rparen. Token.lbrace and token.rbrace. Then we've got token.comma. Semicolon, plus, minus, asterisk, and slash. And then at the very end, we also need to look for EOF. Okay, so now the scan has a call to consume, and consume needs to decide what token to return based on the next byte. So we'll do this with some predicate functions. So we'll say if next is EOF, then we want to return EOF. In the default case, we're going to do unknown. So actually, I missed the unknown case. We'll have unknown, and that will be defined by some syntax I don't support. So we'll put a bunch of at symbols in there. So the default case is that we'll try and find a string of unknown characters to group up. And the way that I do this is by saving the start position and then reading while some predicate is true. So we'll say while it's not whitespace. But rather than saving the start position like this every time, I think I will just return it from readWhile. And readWhile is just going to be responsible for advancing the position of the scanner. So we're going to take a predicate in here, which is going to be a function that takes a byte and returns a boolean. We're going to return the start position when the function was called. And we want to loop while the predicate is true for the next byte, and while we're not at the end of the file. So in the middle of this loop, if we're allowed to advance, we basically just want to increase the position and then set up the next byte. So that's going to be this code again. So we'll put this into update next. Then I can call update next here. And this is basically just reading a single byte. And since we have single byte punctuation, it'll be useful to have this in its own helper as well. So we'll say read. And if we're reading, we'll return the start position and we'll return the byte that we read. So now we just need some predicates. So we'll have is EOF be byte, so that will return bool. That's going to be if we're equal to the EOF sentinel. Not whitespace is going to be the return of not is whitespace. And then is whitespace is where we say that any byte that is a literal space, or it's a tab, or a new line, or a carriage return. We seem to be stuck in an infinite loop, and that is probably because I have white space at the beginning. So what consume needs to do is that it needs to advance or read while there is white space to skip it, and then we can look at the next byte to decide are we gonna return decide what token we're gonna return. Okay, so we want 28, we got 26. So let's try and just figure out. Okay, maybe we'll start with just. Oh, that's so it's saying 26 because it's counting these two as a single run of unknown tokens and these two as well. So we'll start by recognizing identifiers, or maybe we should do punctuation so that we get the correct number of tokens first. So we'll do punctuation first. So we'll say if we're on the start of some punctuation, and it will be punct start because we will have we'll have longer punctuation later, like double equals or like a compound shift assign operator or something. In that case, we'll take the start and the byte from a single read, and we'll look up the kind in a table that we'll define in the token package. So we'll say token.punc1, look up the kind by the bytes, and then return it. So in the token package, we just need a table called punc1. This can be a fixed size array of 256 elements because we're only going to index into it using byte values, and it will map byte values to kinds. So we'll say like the left parenthesis maps to L_n, for example. So we just need is_punc_start. So is_punc_start. And that can basically just return the lookup. So we'll say we'll look up in punc1 by the byte, and if it returns something that's not unknown, then we'll consider it to be valid punctuation. Okay. So now we can see that all of the punctuation is working, unknown is working, and EOF is working. So it's integers and functions and identifiers. So we'll just do integers first. So we'll say this is, we need a predicate called isDigit, where we're going to check if the byte that we're looking at is between the ASCII values 0 and 9. And while we are, I'm going to put consume down next to scan here. So if we find that we're on a digit, we'll say that start equals s.readWhile is digit. So we're going to read a whole digit or a whole number. And then we'll just return token int with the start and the end. So now we'll do identifiers. So if we're on ident start, we'll read while is ident, and then we'll return token ident. So an identifier is basically anything that's the start of an identifier or a digit. Then the start of an identifier is anything that is a letter or an underscore. And anything that's a letter is anything that's between the ASCII lowercase a and lowercase z, and we'll copy this to do uppercase as well. So now we just got function and return to deal with, and these are basically just special cases of identifiers. So the easiest way to deal with this would be to, let's say we'll put on the file, we'll put a new helper function called lexeme. So this will take a start and an end and return a string, and that will just return the substring from the file source. So we'll just switch on the s.file.lexeme, start to s.pos. And in the case that we see fn, oh, this is a punctuation. Let's put the kind into a variable here. So we'll assume that it's an identifier, and if we see fn, we'll say that kind is equal to token.function. And if we see return, we'll change that to return. Okay, so that all passes. Since we've got the lexeme function, we should probably also test the lexemes as well. So we'll put a lexeme into here. So this is going to be file.lexeme, and we'll pass in the token start and the token end. We'll call this got, so we'll say got this, and then we can use, instead of talk.kind, we'll have got over here. So all of these need some lexeme associated with them now. So want this lexeme, got this lexeme. That already looks correct from the test cases there, but I'll put these in manually anyway. EOF will just be an empty string for now. Maybe we'll special case that a bit later. Okay, so that all passes. The final thing that will be useful is to be able to get the line number and the column number for a lexeme, or for a position in the original source. So if I say I want to know the position of the start of this token, I need to be able to ask the file what is the line and col for this offset into the original source. So let's say we'll have line as an integer, or not in 32, we'll just do integer, and we'll do col as an integer. And then we'll just fill out what we expect. So at is on line 2, column 3. Then we got line 3, column 3. This is now 3 later, so that's going to be line 3, column 6. Line 4, column 3. This one is 13 ahead, so we've got column 16. This one is 9 ahead, so we got line 4, column 25. This one will be line 5, column 3, because that's where it starts. This one is 4 ahead of that. So we've got line 4. Wait, 2, 3, 4, 5. Oh, the integers are on line 5. 5, and then I said that the 0 is 4 ahead, so we got 7. All of these digits, or all of these integers are going to be on line 5. So we've got 2 ahead of 7, 2 ahead of 9, 2 ahead of 11, 2 ahead of 13, 17, 19, 21, 23, and 25. Then we got L-paren, so this is going to be the next line, 6 and 3. This is only 1 ahead, so this is 6 and 4. And then we've got the same thing. Oh, this is on the same line actually as the parens, so this is 2 ahead, so 6 and 6. 6 and 7. Then we got 2 ahead again, so we got 6 and 9. This one is also 2 ahead, so we've got 6 and 11. Then we got 7 and 3, and then we just go up in 2s here as well. So 5, then we've got 7, 7, and then 7, 9. And then the EOF is on line 8, but column 2, because the raw string ends one place outdented. So we'll say if for this we want to actually query the column, the line and column. So we'll say file.linecol, and we'll pass in the token's start offset. So if tc.line does not equal line, or the tc.col does not equal col, then we'll generate an error. So we'll say t.errorf want line col, this got this. So this will be tc.line, tc.col, and then line col. And then we need to add line col as a function. So we've got line col. This will take some offset into the original source, and it will return the line and column. I'll just hardcode these as zeros so I can see if the tests fail. Okay, so the way I'll do this is I'll have a lines cache, and this slice is basically going to be the index of the slice is the line number, and it maps to the offset that the line starts at. So the first line will be index 0, offset 0, because that's where line 1 starts. And we'll just lazily initialize this because we only need it if we're generating things like errors. So we'll say if lines is nil, then in that case we'll append 0, because we always have at least one line. Then we just need to go over all of the source bytes. So we'll say I0 to I less than the length of f.source, I++. If the byte that we're looking at is the new line, then that means it's the end of the previous line that we care about, so we should +1 to get the start of the next line, or the start of the current line that we care about appending. So we'll append I+1. So now this line slice is basically a slice of increasing integers, so they're already sorted. So if we want to find the line number, we just need the index, so we just need to search the line slice for the offset. And Go has this function in the slices package, binary search, which we can use because it's already sorted. And we're going to search for the offset. So if it finds the offset, it will just give us the exact index, which will be the line number. If it doesn't find it, then it tells us what index it would be at. And the only way we're not going to find it is if we're too far ahead of the line. So line is always going to be one more than we need. So if OK is false, we need to just decrement line. Then we can use that index to look up in lines to get the starting offset. And then we can use the difference of the offset we're searching for and the start of the line to get the column. So this will be line +1, and this will be col +1, because they're all 0 indexed. Undefined lines, this should be line. And that all passes. So we can successfully tokenize a source input, which populates file.tokens. We can get lexemes, and we can get the lines and cols. So basically, next I can pass this file to a parser to consume all of the tokens and build an AST.